So now I want to solve some story problems, and these story problems are going to have quadratic equations in them. So the first one that we're going to do is using a Pythagorean theorem. So the Pythagorean theorem, most people are able to rattle off, right? We know that that one is a squared plus b squared equals c squared. But just in case, let's make sure that you know what everything stands for. So this relates the lengths of the sides of a right triangle. So a right triangle has a 90-degree angle in it. A and B, these are the legs of the triangle. It doesn't matter which one's A and which one's B. It does matter that C, or whatever you have kind of alone on one side of the equal sign, is the hypotenuse, which is the side that's across from the 90-degree angle and also the longest side. Okay, so let's go ahead and take a look. So a 26-foot ladder is leaning against a building. If the bottom of the ladder is 10 feet from the house, building, how high does the ladder reach? Okay, so draw my building / house. And so 26 feet, that's how long the ladder is. It's telling me the hypotenuse, right? It's leaning at an angle against. And let's see, it's 26 feet long, so I'll go ahead and label that. And the bottom of the ladder is 10 feet from the house. Okay, and here is that right angle. How high does the ladder reach, right? So the thing that we don't know is this h. Now you don't have to use A, B, and C. You can use whatever letter, so I'll use h for the height. Okay, that's our unknown. That's what we need to figure out. So I have, right, three lengths of the sides of a triangle. So here we go. So we'll say 10 squared plus h squared equals 26 squared. Okay, now it is super tempting at this stage to want to take the square root of both sides because you just have all those squares, and wouldn't it be nice if they all just went away? Well, right, if we could just make them go away, then we would have done that way back at the beginning, right? We wouldn't have squared them at all. If we were just going to say that, right, 10 plus h is 26, we wouldn't have a squared plus b squared is c squared. We'd just have a plus b equals c, and we don't. Okay? So I can't just take the square root of everybody, so let's go ahead and just square the numbers that we've got. So I have 100 plus h squared equals, let's see, 26 squared is 676. Okay, now I have a squared. So when you have a squared, right, one of the ways that we can solve these is to get a 0 right on one side of the equal sign. But I'm kind of looking ahead and seeing what I've got. What I don't have anywhere in my equation is an h to the first power. So that's kind of good. So if I just have an h squared and everybody else is a number, then one of the ways I can solve this is to get the h squared by itself. So I'm going to subtract 100 from both sides. So h squared equals 576. Okay, now. And then I can. So now that I just have a single h squared and it equals just a number, now is when you can take the square root of both sides. Okay, so I square root h squared, and the square root of h squared just gives you h, and the square root of 576, let's see, square root of 576 is 24. And our units were feet. Now, I'm going to say this would have worked. Let me grab my green pen again. We could have totally solved this. I was just kind of looking ahead again. Come back up here to the 100 plus h squared equals 676. And you say, okay, well, I know that I'm supposed to get a 0, so I'm going to subtract 676 from both sides. And then I'm going to rearrange it so that I have h squared minus, 576 equals 0. So you could have gone this way and then factored, right? This would have been a plus and a minus. So plus 24 and minus 24. But I knew I wasn't going to get those 24s because I was not going to come up with factors of 576. Just not, I just didn't know what they were. So I knew I had this square root idea that I could use because I didn't have any, like I said, any h to the first powers for a term. Okay, here's another Pythagorean Theorem question. So guy wire is attached to the top of an antenna and anchored 9 feet from the base of the antenna. If the antenna is 3 feet shorter than the guy wire, how long is the guy wire? So that guy wire is playing the role of Pythagorean theorem, right? So here's our antenna. Here's the guy wire coming down to the ground. It says it's anchored 9 feet away from the base, and the antenna is 3 feet shorter than the guy wire. How long is the guy wire? So since how long is the guy wire, that's our unknown. So again, you could use the C if you wanted because it's playing the role of the hypotenuse. I'm going to just let it be X though because I just feel, I don't know. It's what's speaking to me right now. So if that's X for the guy wire, the thing we're looking for, now this says the antenna is 3 feet shorter than the guy wire. So if the guy wire is X, the antenna is 3 feet shorter than that, so X minus 3. There's your right angle. Right, so now we have a picture that has the lengths of the sides of a right triangle all labeled. All right, so that's what we're going to use. So Pythagorean theorem, here we go. So 9 squared plus x minus 3 squared. Notice how I used parentheses because x minus 3 is more than one term and I need to square the whole thing. And then that equals x squared. Okay, so we got a quadratic thing going on here. So we're going to go ahead and simplify this binomial squared. We'll square the 9. Let's see what we get. 81 plus. So square that out. And you can do a little workspace up here if you want. X minus 3 times x minus 3. So we'll get x squared minus 6x, right? So minus 3x, and then plus 9. So I'm going to replace that x minus 3 squared with those 3 terms. Here we go. 81 plus x squared minus 6x plus 9 equals x squared. Okay, now I have x squares. So when we have x squares, right, unless we have the square root thing, but I can't because I've got this minus 6x, so I can't just square root things. So we're going to go ahead and try to gather, right, get a 0 on one side. So when I do that, right, the right side would be the most obvious. So I will subtract x squared from both sides, lining it up on the left with the other like term. So now I've got my 0 for the right, which is great. But notice what happened over here with my x squares. Right, they're completely gone. And so now we have 81. I can go ahead and add that to the 9. 81 plus 9 is 90. So 90 minus 6x equals 0. That's the equivalent equation that I come up with. Now that equation actually isn't quadratic anymore, right? It's linear. So now I have to think, okay, well, how do I solve equations that are linear? Well, we do that by getting the x term by itself. So now I'm going to add 6x to both sides. Come up here. So now we have 90 equals 6x. And then divide by the 6. Same thing both sides. So x is, let's see, 90 over 6 is 15. So 15 feet for the guy wire. And that means the antenna is 12. Okay. Area. Area is another common quadratic story problem. So area, looks like we've got, oh, I didn't say, it's a rectangular addition. So rectangular addition. So I'm going to draw a rectangle. And the area, so I know it's area because it's square feet. Square feet, square anything is area. 420 square feet. And it is 1 foot longer than it is wide. So the length is 1 foot longer than the width. So I'll let W be the width. So then the length is W plus 1. Okay. So the area of a rectangle, multiply the dimensions, length times width, length now being played by W plus 1. So W times W plus 1 equals 420. Distribute the W, W squared plus W. Okay, so quadratic, that means the right side needs to be 0. So subtract the 420 from both sides. So minus 420 equals 0. And then we're going to factor. So now we have to find a pair of factors, right? Two numbers that'll multiply to give me negative 420, but add to give me 1, right? This plus 1w. So you can have, right, just a little 420. Just go through all the numbers that'll go into 420. Right? You can start small. You can start maybe at, right, 2, I think I got up to 10 times 42. And then I saw, oh, hey, if I grab a 2 from the 42, that'll make this a 20. And coming out of that makes it 21. So it's a 20 times 21. These two will multiply to give me the 420, right? And if I make the 21 positive and the 20 negative, it'll also give me the plus 1w there. So let's go w minus 20 and w plus 21. So there's your negative 420. Outer, inner give you your 1w. So multiplication equals 0. So then either w minus 20 equals 0 or w plus 21 equals 0. So w equals 20 or w equals negative 21. Now, negative 21 doesn't make sense because we're talking about, right, the length of the cabin. So the width is 20 feet. And it says the dimension, so it wants both. So if the width is 20 feet, I'll sneak it up here. The length is 1 more than that, right? So 21 feet. Okay, here's another area question. Length of a rectangular raised bed garden is 4 feet longer. Okay, so the length is 4 feet longer than the width. W plus 4, width is just W. Total area 96 square feet again. What are the dimensions of the raised bed? Okay, this is just like the question we did. So W times W plus 4 equals, right? So length, width times length, 96. Distribute, move the 96 over so you get a 0. W squared plus 4W minus 96 is 0. Oh, factors of 96. 96. Right, so I'm just going to, this one I didn't write down, so I'll have to go through. So what do I have? 96 divided by 2. So I've got 2 and 48. 96 divided by 3. I got 3 and 32. 96 divided by 4. 4 and 24. Remember, I'm looking for something that will subtract to give me 4. Okay? 96 divided by 6. 6 and 16. What else? Let's see. 96 divided by 9. No, 9 won't go into it. 10. No. 8. 8 and 12. Oh, there we go. 8 and 12. Cool. So, right, if I make one of them, so one has to be positive, one has to be negative. So they multiply to give me negative 96. I want my W to be positive, so that means that 12 is positive. 8's negative. So I'm going to get W minus 8 times W plus 12 equals 0. W minus 8 equals 0. Or W plus 12 equals 0. So W equals 8 or W equals negative 12. Again, negative dimension doesn't make sense, so cancel that one. So 8 feet for the width, and that means the length is, right, 4 more than that. So 4 plus 8 is 12. Okay, 2 more. Here we go. Oh gosh, here's another area question. Rectangle. Area 24 square meters. If the length is 6 times longer than it is wide, so 6W, W, what are the dimensions of the rectangle? Just one rectangle. Right, so area, length times width. So width times, but instead of putting an L, we're going to do the 6W, right? Because it's nice if we only have the one letter because that's what we can solve. So W times 6W, so that's 6W squared equals 24. So here's another example like our first Pythagorean theorem where I don't have a W to the first power. I just have this W squared and everything else is just a number. So I'm going to divide this 6 again. W squared equals 24 over 6 is 4. So if W squared is 4, what is W? Right, so we can square root. So W is 2, and looks like we're meters. So if the width is 2 meters, what would the length be? Right, 6 times that, so 6 times 2 is 12. Okay, here we go, last one. Sometimes, right, you just get given a formula. Now you might think, well, awesome, that makes it so much nicer. So one thing I'm going to suggest that you do is when this happens, that you go ahead and write down what all the letters stand for. Okay, so the number of games in a sports league where X teams play each other team twice. So X is the number of teams. Is given by, so this is our formula. Oh, so the number of games in a sports league where X teams play each other team twice is given by N. So N is the number of games. Okay. And then we have the formula. In a given league, if there are 132 games, that's going to be my N. So N equals 132. How many teams, X equals, don't know, are there in the league? Okay, oh, we can do that then. We're going to grab our formula. So N is going to be the number 132. So 132 equals X squared minus X. And we're supposed to come up with the X value. Okay. So squared, I can't just square root because I've got this X to the first term hanging out. So that means I need a 0. So subtract your 132 to both sides. And now I'm looking for a pair of factors of 132. Again, I don't know what those are, so I'm going to just start. I know I want to subtract to give this 1 here, so I'm not going to start with 2. I'm going to jump up a little bit, maybe 8. 8 times what? So 132 divided by 8. Oh, nope, that didn't go nicely. How about 132 divided by 4? So I've got 4 and 33. Oh, to 6. 132 divided by 6. 6 and 22. Okay, we're getting closer. I don't know if you notice here, but I've got 33, I've got 22, so I'm going to get 11 is going to have to be one of those factors, so I'm going to divide that in. So 132 divided by 11, 12. There it is. There's my pair, 12 and 11. One's going to have to be negative to get me the negative 132. We're going to figure it out here with my negative X, 12 and 11. I want the X to be negative, so I'll put my negative with the bigger number here. Still equals 0. So product equals 0, so either X minus 12 equals 0 or X plus 11 equals 0. So X equals 12 or X equals negative 11. So negative 11, doesn't make sense, so we won't keep that one. So there must be 12 teams in the league.